Hi there, can you hear me, everyone? Thumbs up if you can.
Yeah, we can hear you.
Excellent. Yeah, we're quite sure technically whether I've set this up correctly, so excellent, good. And get this up on there we are. Right, I've got my video as well. Right, well, welcome. This is Core Concepts Data Vault, and nice to see you in. We've got 1, 2, 3, 4, 5, 6, 7, 8 people in. We've got a few more registered, and maybe they'll turn up in due course. But it's nice to see you all in here. Just excuse me for a moment. I need to grab something from the printer, and I'll get started. So, right, we are basically this is the Data Vault Core Concepts presentation. Like a mini course come seminar about Data Vault. The objectives of today are to bring you up to speed with Data Vault, what it is, what it's about. So I don't know about you, but when I first started to learn about Data Vault, there was a real lack of information on the internet about what it was. So you'll start your research, you'd find out a little bit, and then you hit a paywall very quickly for an expensive training class. And in the end, I took the class and was very happy about it, but it was a bit of a jump of faith in terms of what was there. And this makes it difficult because if you can't find out a lot about Data Vault, how can you make a decision about whether you want to invest in it or not, or use it in your organization? So the aim of today is really to bring you up to speed so you can have a reasonable discussion about Data Vault and decide if it's for you or not. So you've got 2 hours, or maybe just under 2 hours. A full class is 3 or 4 days long, so I have to do a very high level overview for you. So the aim of today really is you should be able to explain what Data Vault is to other people. You should understand what it brings to your organization. You should be able to describe what a hub, link, and satellite is, and understand how their loading patterns work, and to appreciate what it takes to implement Data Vault in your organization. So in terms of that, we've got an agenda. So it's 2 hours, so I'm going to have 2 parts to it, and we're going to have some introductions first, a little bit about Data Vault and how work changes, challenges for today and future, and look at a case study. And then on part 2, going to technical details. So looking at the case study, how we do the data modeling, how we build out a working solution, the conclusion, and going forward from there. Okay, so that's where we are, and I'm going to hide my video now so I don't disturb you, and we can move on. No recording will be available for this. We run this live every 2 weeks. If you want someone else to attend, we're very happy to take people in on a request basis, every 2 weeks we run this as a marketing exercise. Okay, right. So here I am. This is me. I'm Neil Strange. I am. I guess I'm developing into a bit of a Data Vault guru at the moment. I specialise in Data Vault. Well, originally I'm a sort of science background, so I'm a physics graduate from London University. I've been in consultancy all my life, both management consultancy and IT consultancy. And I think, BI is quite an interesting thing because it kind of sits in the middle between management and IT. I chair the Data Vault user group. And if you want to check our website out, it's there, datavault.com. My email if you want to be in touch with me. In terms of our business, we do everything related to Data Vault, from sort of strategy and architecture and governance work, all the way through migrating your data platform, data science applications, developing skills, dashboard development, and so on. And we're increasingly seeing data mesh and medallion type architectures as well coming into the mix. And Data Vault plays very well with both of those architectures. So a range of services. We also are the authors of Automate DB, which is a free tool for use with Data Vault that works with DBT. So if you are a DBT user, you can access this package for free and use it as a generator, an automated generator for building a Data Vault. We're very pleased with this tool. It's got multi-database support. It's tested very thoroughly, which means it just works, and we have some confidence that it's working correctly. We also offer training. So if you like what you hear in these 2 hours, we have a two full day delivering option where we simulate a project and come in as a developer and learn how to build out the Data Vault using that project as a case study. Target is Snowflake. If you're interested in learning more after today, there's the QR code for you to access the material on that. And finally, we have a user group with monthly online meetings with a guest speaker, free materials, regular newsletter, and so on. If you go to that user group, you'll find downloads, you'll find video recordings of this monthly meetup that we have, and we get some good speakers in there. So, for example, just before the summer break, we had Bill Inmon in there presenting to us about his latest ideas on text analytics. And other authors and key speakers as well come in across the time. We've got about 60 meetings documented, available for you to look at. And finally, we have, as part of the user group, we have a conference coming up. If you're in the UK or planning to be in the area around the 11th and 12th of September, we have our second conference. So first one last year, second one coming up this year. It's promising to look like a very good turnout. Lots of presentations, good presentations, and again, big focus on things like data contracts and how Data Vault can be embedded and used inside organizations. Interested? Follow the QR code at the bottom. The agenda's on the website. You can check out what we have to offer you if you wanted to attend. Right, enough about us. It'd be nice if you could introduce yourselves, please, to me. If you could just, I'll go down the list one at a time. And if you could just say hi, who you are, what's your role, what do you know about Data Vault, and anything you'd like to get out of today. And I'll go down alphabetically, so call you out one at a time. And the first one on the list is Ajit. So if you could introduce yourself, please.
Hi, Neil. My name is Ajit. I'm data architect and working for Condé Nast Technologies.
Yep.
I don't have experience in Data Vault, but I have use cases where I have to apply the Data Vault. So I have to basically create a Data Vault for PI. Right now, many people can access PI, and a company wants to just create a Data Vault for those PI information, so that selected applications and people can use the PI informations. Yeah, this is overall introduction about me.
Wonderful, thank you. Right, so the next one is that Karen? Can you introduce yourself, Karen? Oh, okay. Nitish, can you please introduce yourself?
Yeah, hi. Hello, everyone. So I'm Nitish. I'm currently working as Snowflake data engineer. So in our project, I've seen some DBT Data Vault implementation already. So with my interest, I have learned how previously I implemented dimension modeling in Snowflake, but after going through the Data Vault, so it was my interest to learn about the Data Vault, and I came across through the CDVP, and I've registered for this.
Okay, thank you. Next would be Paul, please.
Afternoon, everyone. So my name's Paul Bowdenay. I work for Clarion Housing Group in the UK as a data engineer, a relatively new data engineer, by the way. So my experience with Data Vault is very minimal and simply just wanting to learn a lot about, or as much as possible about Data Vault because our company is likely to move towards it.
I think you already have, actually.
Yeah,
So,
yeah, we have. Yeah.
Okay. Thank you. I've just sent a report in to you this morning.
Okay. Thanks, Neil.
All right, you're welcome. Next one is Raj, please.
Hi guys, hi everyone. I'm Raj. I'm from India. I'm a senior data engineering architect. So I've gone through a few articles on Medium and other blogs. So I want to learn more about data work. So accidentally I've gone through a few articles and then I saw this link and I registered.
Lovely, thank you. Sai Krishna next, please.
Hi, Sai Krishna here. I'm working as a data engineer. So in one of my recent assignment, team is going to use Data Vault. So I started digging the Data Vault in all the internet, but I haven't found any good items over there. So when I was checking the Data Vault site, I could see there is some registrations is going on. Actually, I have registered last time also, but I missed to join. That's why I want to know about Data Vault and how it is using, how it is going to use in my project perspective. So I want to know about how it is like that.
Okay, thank you. And Stephen?
Yeah, good afternoon. I'm Stephen. I also work for Clarion Housing Group in the UK. We're just migrating from Azure to Snowflake and Data Vault, and some of the team are a bit more ahead in the process than Paul and myself. So Paul and I are joining this for an overview of Data Vault.
Great. And finally, Supriya, please.
Sorry, this is Sudhir, and I am using my daughter's computer, so it's famous Supriya. Sorry for that. So I'm currently working on a Snowflake side. So I would like to understand how Data Vault is different from other data modeling, whatever it is existing in today we're using. So I want to understand the new data models that are being coming, like as you said in earlier, Metal-ADN. So just want to understand those new frameworks also, which helps for Snowflake part. Maybe best practices or challenges you face normally as beginners, right? What we need to more about data.
See what I can manage. There's a lot to cover in the 2 hours, but you can ask me questions as we go. That's no problem.
Yeah.
Okay. All right then. Let's get moving. Right. So I think we should set a context here. What's the future of BI? I think things have shifted quite dramatically over the last few months in terms of where BI is heading and the purpose for business intelligence in an organisation. And I don't mean business intelligence on its own. I think the whole area of data warehousing, data platforms involved. And I guess if you want to look at this in a simple sense, this is it. This is the future. We've got users who are going to be increasingly asking questions and using some kind of Gen AI chat area, specialized chat for supporting their roles. Still doing dashboards, still taking data sets out in Excel spreadsheets, playing with data, but increasingly asking questions and using that information for business benefit. On top of that, they'll be having agents who can assist them with their work, act for them on behalf of them to perform certain processes, or even agents acting as middle management and controlling and directing people according to work allocation rules. So, a very much different world from where we've been recently. Of course, this is great. This is what your users see, but behind the scenes, you need a data platform to help drive these things. And the data platform's role is to sort of clear up the data from operational systems and present it in a consumable format to the AI engines that you have to dashboards and data set extracts and reports that you're running for your end users. But also that platform will be used by your agents and assistants to learn from and to feed information back into in terms of company performance. So very much invisible behind the scenes, but very important to drive this new world. Now, your end users, they're going to be using the information they have for delivering business advantage. So it's going to have a big impact on their personal productivity. They're going to have a better grip on the operational side of the business. Service quality is going to improve. They'll be able to innovate a bit more and maybe have more reduction in mistakes and rework. And Harvard Business Review's done some work on this and has come up with some numbers, and they think that the new world is going to give a whole new layer of productivity and benefits to organisations. And whether you believe in it or not, these numbers are calculated by the Harvard Business Review. They've got to be close there or thereabouts. So 54% increase in revenue, that means a big increase in revenue purely by embedding these new tools. So your data platform is going to be even more critical and even more embedded in the generation of value for the business. This can't be delivered to these numbers unless you have good, clean data coming in. And you're going to be using your data to augment what's available from external sources as well. So you're going to be mixing together your knowledge bases, your structured data sources, your operational systems, documents, video, sound, and external data to produce your Gen AI applications for the business. Now, these traditional stuff doesn't go away. So Gen AI is dominating the discussion at the moment, but you're going to be doing the same old structured reporting and analytics, and supporting your data science, Internet of Things, unstructured data use cases. So your data platform behind the scenes has to be multi-purpose, has to support all kinds of use cases there, which means it's going to be large, it's got to be well organized, it's got to be full of good quality data and demonstrably good quality data for the consumption. Now, you're all data engineers, so users don't see what goes on underneath. And whatever way you build up your data platform, you end up with these data pipelines. So tables feeding tables up a stack until you get to a consumable format for your end users to access. And part of the problems you've got here is that as the use cases grow in the artificial intelligence field, the number of tables, the number of transformations required is going to grow larger and larger and larger. And there comes a problem of your manageability of the platform. So you need to have an architecture that's really designed for scalability in there, so that you can keep adding to it without losing track of what you have. So in the future, we're going to see these sorts of challenges. Okay, so technically, we've largely solved the problem. Technically, we can build you pipelines. Technically, we can feed good quality data to your question generator. But these are the issues that are still to be resolved. So how do you avoid getting just lost in the technology? You need to maintain a business focus when you do this work. How can you get this semantic integration? You need to integrate by concept so that the data is labeled properly. How do we scale? How do we manage the lineage and auditability in there, explainability? All these things. And a big one that's coming down, which isn't hitting many people yet, is ethics, AI ethics. Are we using AI for the right purposes? And if you're going to do this, it'd be a good idea if you can adopt a method. So if you're going to take raw data and deliver value from it, doesn't matter what method you use, you're still going to have to do the same kind of transformations to that data to get from raw to value. And the different methods out there, Datavault included, they differ in how you do those transformations and what order you perform them. But the work still needs to be done. So, for example, how these methods differ is listed underneath. So, for example, if I'm running a traditional data lake, the belief in data lake is that we store the raw data in the lake and then tell the users access the raw data and do the rest of the work yourself effectively to get the value out of it. Others, highly centralized methods, might say, well, we can't trust users to do anything, so we do all the work and just expose simple data sets to users to use for management. So all these methods vary in different ways, and Datavault really is just one way to build out your data platform. What I would say, and you'll probably find out through the presentation, that it's actually specifically designed to meet what you need to do today. So it's it has answers to most of these challenges that we've mentioned already. Datavault was invented by Dan Lidstedt. This is his definition here. I want to pick out a couple of words from here. So he talks about it being a system of business intelligence. So a system is not just data modeling. When you first see Datavault 2, you get an idea of these hubs, links, and satellites, but it's more than that. It's an architecture. It provides you with SQL patterns for data load. It gives you information about ways of working and data modeling on top of that. So it's a system. The second thing is about enterprise vision. So if you're trying to build a picture of the business, you're going to be bringing in information from multiple source systems, and we want integration. We want to build up a joined up view of the data, cleaned up view of the data, which is sort of enterprise scale. So we're going to be loading lots of systems data. We want to be doing this in an incremental way. So we need to be able to apply agile practices here, build a bit at a time and add to it over time, growing incrementally. Datavault is also best when we're joining different data sources together. So, for example, we're bringing in data from a finance system and maybe an operational system as well. Joining those two data sets together largely gives more insights than just a single data source on its own. So Datavault's really all about building, it's a system for building out an enterprise vision data warehouse. And if you're looking for Datavault, why do organizations choose Datavault? Well, usually building a warehouse is an expensive undertaking. So normally your current data platform has to be broken. So it's not fit for purpose, won't meet future business needs, and whatever you need in the future needs these sorts of features. So integration, auditability, agility, enterprise, and so on. Datavault has good support for all of those sorts of features, which makes it a good candidate as a method to choose to build your new platform with. Okay, all right so far? Am I speaking clearly enough for you? Put your yellow hand up if you're happy. Yep, good, thank you. All right, so what happens when we use Datavault? We'll do a little thought exercise here. Go find your favorite manager. We're going to freeze them. We're going to put them into a freezer. We're going to implement Datavault. Then we're going to defrost them and walk them around the office and ask them what's changed since they disappeared. And most of them will mention about one of 6 things. So what are the highlights of change that you'll expect? First of this is ETL. So a lot of the code that you were originally developing would have been hand-coded, and Datavault is designed for code generation. A lot of vendors quote 95%, 90% of code can be generated. I think it very much depends on your local circumstances. So how many business rules you have to code and so on in there. But the answer is it's a significant percentage can be generated. So by generation, that gives us consistent, high quality code just produced from the metadata that you're working with. And what's left behind, the 5%, is for your customized pieces. So work here, so business rules, testing. How many of you got a test harness around your current warehouse? Not many customers I visit have a good test harness in place. We're moving away from hand-coded and more code being generated. And because of that, the team members are now far more productive. So we typically see about a 500% improvement in output per team member. Can see more. But what's left behind is the slightly more complicated code to be written. So we tend to see smaller, slightly more senior teams in place, and those teams tend to be doing data ops, so they're supporting the system as well as building it. And team members, because it's a smaller team, everyone's developing the full stack of skills. So that's great as motivation for people to stay with an organisation. Dave talks Agile. Some other methods are very, very difficult to apply using Agile techniques. So Datavault comes with the ability to do incremental development, refactoring, test-driven development, and more frequent deployments and so on. So you can start using those techniques, and if you apply them correctly, you'll end up with less stress, less risk, faster iterations. I've got a story here about a customer I worked with a couple of years ago, and they were a very good engineering organization, but they had a legacy data warehouse written in Oracle. And they had 500,000 lines of code which loaded data into their old warehouse. And that code had been written over quite a few years, and a lot of the original developers had left. And the code was littered with comments, things like, don't understand what this bit of code does, please leave alone, and so on. And it was basically very difficult code base to maintain and manage. When they did deployments, they would have 4 windows a year for deployment. So every 3 months, they would come in for a weekend and do a deployment. And that work would involve, backing up the warehouse on a Friday afternoon after detaching all the feeds, applying updates, checking that they worked, fixing anything that didn't work. And often they're working through Saturday and into Sunday, fixing code, making sure they can get it to run. And if it works by about Sunday lunchtime, they deploy and push ahead. If it's not working by Sunday lunchtime, they initiate a rollback for the warehouse itself, which would tend to run till possibly late Monday or even Tuesday to do the rollback properly. And then if they failed the deployment, they'd have to come back the following weekend. So they're basically getting one deployment every 3 months. I worked with them for about a year, and in that year, they went from a deployment every 3 months to 3 deployments a week. And they also were able to bring in 1,100 data sources in just over 11 months. So bringing in lots and lots of sources in different languages. So they had Swedish, Japanese, English, German, all kinds of languages being processed, all data arriving inside the one warehouse. And there's far less stress in there and more agility in terms of their response to business needs. If you are working in an agile way, then Agile talks about you continually learning. Now, this is really about mistakes. So mistake isn't really a good word. I think handling learning might be a better way of putting it here. So if you're working with a traditional warehouse method, if you are implementing a new data set, you better get it right, because rework of making corrections is quite expensive and quite difficult to do. In fact, in many cases, you end up throwing away what you've done and redeveloping it again from scratch. So you need to get it right, and you need to put a lot of time into the design to get the system running properly. With Data Vault, because we can do refactoring very easily, rather than sit down and over-design and worry about all the small elements of the process, you can just push ahead and experiment, build something and learn from it. And if it doesn't quite work, you can refactor it and correct where you have concerns. So, for example, if you're not sure about two options, you could build the system like this or build it like that. Rather than worrying about which option to build, just pick one, build it, learn from it, and if it's wrong, use the alternative. Or even build both at the same time and learn from one and switch one off and the other one on if it performs better. So it gives you a lot more freedom and flexibility to just push ahead and build things and learn from it. If you're generating code, you're going to be working with metadata. And by metadata, I mean data models, data mapping, metadata management. So this metadata is part of your regular work. You're going to be managing metadata sets and generating code from that rather than a lot of routine coding. Okay, so you'll be working in a more abstract level. And finally, the architecture. Well, Data Vault has a easily extensible architecture. Now, this means that if I build a really tiny warehouse and I want to grow it and I want to go up to sort of petabyte scale, I can do that without having to stop and re-engineer the architecture. So if I'm working with tools like Snowflake, for example, I can grow by just adding more processing power or more storage area for my data. So I can scale up and up and up. There's no need to stop at some point and re-engineer or reload something. The architecture just grows. Okay, now let's talk a bit about the case study, and then we'll get back to, after that, talking a little bit about more where Data Vault comes from, and then we'll go back to the case study in the second part of the presentation. So we've got here a furniture business, which is called Hyper Furniture. We've made all this up, of course, and the challenge is that they need to build out a new data platform. They've chosen Data Vault as the method to do that. Now, they've got a project to run, and just like a good Data Vault, a good agile development approach, they need to add value. So they've looked around in the business for a use case, and they found a marketing team that need to run a campaign. They need to do some basket analysis to improve their upsells. Someone who bought this furniture also bought these items, and they want to do that. And they think if they do this properly, they'll add about 500,000, $500,000 to the business revenue, which is enough to pay for the project. They want this done quickly, and they're running a cloud database and storage. So solve this problem. They have found two source systems in the organization, the CRM and order management system. They hold information about purchases, and each of those has tables, interests, so there may be hundreds of tables in each of these systems. We're going to go right down to just a small sample set to be agile. And these tables have typical schemas. They've got various spellings of similar concepts, and typical of what you'd see in a source system. So we've got contact and address in CRM, customers' orders, lines, and products in the order management system. And this is what we're going to build out. On the left, you can see our two sources, the CRM and order management systems. And also we have other source systems we will add over time as the warehouse grows. Data Vault itself is there in the middle. This is our integrated view of data. So the Data Vault's there, the hubs, links and satellites are there. And we're going to cut a business product out there for use by the analysts and managers in the marketing team. But there are other use cases. We may be producing other data products in the future from that data set. Right, analytics. Where does it come from? Now, before COVID happened, I used to go regularly into London and attend meetups for the fintech businesses there. East London's well known for a lot of fintech activity, and I go along. We'd have an evening meetup, so there'd be a presentation, a break for beer and pizza, and during the break, people would ask me what I did for a living, and I'd say, well, I develop data warehouses, and they'd be very sad. They'd shake their heads and say, oh dear, never mind. We didn't think people built warehouses anymore. Which made me a bit worried that I was becoming a bit of a dinosaur. But then I realised, of course, well, no, these are startups. And startups are here at the left of this maturity journey. So they're much simpler organisations. They have a few use cases. Their data's been coming from systems they've largely built themselves. They're working in, they've got very good technical skills and a very small number of use cases for their analytics. On the other hand, I deal with bigger companies, the ones on the right. Those have been around for a while, and they have all kinds of issues inside a business, like lots and lots of use cases, lots of systems, small number or very large number of developers, and they're doing all kinds of projects with all kinds of technologies. So you can see the larger firms are very much more complicated than the smaller firm, and we find that basically data warehousing architecturally fits better into that those firms, the ones that have been around for longer. It helps simplify some of the complexity in the architecture by having a collection point for data. So, what do we see in the startups? This is how they do their reporting. Yeah, they've got source systems. They take data out of the database, build a pipeline, and push data out in a spreadsheet or dashboard for management. And if I want to build another report, I just build another one. If I need to build more, I'll keep going. Okay, so this is okay, but there are problems with this. The problems really are to do with scale. If I keep adding to the list here, I end up with a bit of a code maintenance nightmare. Yeah, because you're going to have some code, common code across multiple reports, particularly if you're querying and processing some data in a consistent way. So you're going to end up with management coming back and saying, you know, that report you sent me, can you please add a bit to it? Can you modify it here? Can you modify it a bit there? And by modifying one report, you then find there's a cascading impact on other reports that have similar queries in them, and you just end up with a maintenance nightmare of going around in circles handling these. And I think that's obvious, because when I attended one of the meetups, there was a company stood up and said they built 30 of these things, and the team now was full-time running around in circles doing code management, and they couldn't work out why they couldn't make further progress in building out new reports. So great, you can start off very simply this way, but you're going to very, very quickly end up in problems with scaling. That's why data warehouses evolved. They're a way of sort of isolating the source systems from the analytics use cases. That gives you a sort of control mechanism to do your reporting against. It also means you can optimize the store for your reporting needs. So That's the origin of data warehousing. Now, once data warehousing started, there were two main design philosophies out there. One promoted by Ralph Kimball, which was related to star schemas, and the other one, Bill Inmon, who had things to say about operational data stores and the enterprise data warehouses. And their two methods were different from each other, so they had different people supporting them in terms of popularity. And let's have a look inside these. So Kimball's a technique for star schemas that I see in a lot of organisations. A lot of my clients use them. They've been around for quite a while, since the early 90s. There's plenty of books published on how to develop them. And Kimball basically said, well, look at your source systems. They're not suitable for optimized for reporting purposes. So what you need to do, he said, was to build in these data products, these star schemas. And what you did was you built a small an analytics data set for particular use cases. So here we have profit and loss, a star schema that's probably going to be used by the finance team. We've got a customer churn data set that's probably going to be used by the customer experience team, and a customer service block used by maybe the service desk manager. Okay, so we're cutting out particular use cases for consumption, and we're building these in a star schema way. So we've got dimensions and fact tables in there. And this is all right, very well, but maybe at some point you may want to join these together. So for example, maybe customer churn is related to customer service. Yes, bad service, someone leaves us. So I want to analyze data across two separate star schemas. I need to join them together. So to do that, I need to create these things called conform dimensions. So these are like common dimensions that can be shared across these spot solutions. You'd find in an organization there's about 30 to 50 of these confirmed dimensions that could be built. Okay, so we're off. And the issue is, when I go into clients and look and see where they're going with their BI systems, I see a small number of star schemas there, but not many, maybe 7 at most, and not many others built. If you ask people, why did you only build 7? Why aren't you building more of them? What the answer tends to be is, well, we built our first star schema, and that went in quite quickly, and our users were happy with that. We then built a second star schema, and again, people were happy with that. Then we built the third one, and the work started to slow down a bit. And we built a fourth and a fifth, and by the time we got to the sixth one, what was taking us 2 to 3 months to do initially is now taking us over a year. So what we're finding is that the star schemas, they are great. They're very much supported by your end users. They love to work within the star schema ideal. But the architecture, as it grows, becomes increasingly not scalable. So it's taking longer and longer and longer to develop things. So Kimball's great for users, but not scalable. Inmon. He said, your source systems, the data models in your source systems are physical. They're designed to drive computer screens. Okay? So if I dive into one of these systems, I'm going to see hundreds of tables in those systems. And I can often trace a screen back to a particular table in there. So it's in the vendor's interest always to add new features to their product. So they're always playing with the data model behind the scenes, and they're always growing the data model perhaps in ways that are less efficient than if they designed it from scratch. So Bill's view is, well, management don't need to know the complexity of these sources. What management wants is a simpler view of the business. So management have this mindset, this mind view of what a business is. If you can model that in a third normal form, and then force fit the sources into that simplified model, you're going to end up with a good quality data reporting set from which you can build out some data products. Now, Bill didn't say what these data products should be, but he did say he likes this star schema method. Maybe you could use star schemas to report from the enterprise warehouse layer. And that makes a lot of sense. Now, there are problems with this, though. Perhaps the biggest problem is that it takes a long time to develop this. If I'm starting on the process, sometimes it takes 6 months, a year and a half before we're ready to cut the first data products out, and it's far too long, and users won't wait that kind of time. So by the time you get there, they found a way around you, undermines the need for the project rather. So basically, Inmon is slow, so it's not user-friendly in terms of being responsive. However, it does scale very well. So can you imagine here, we've got one method which scales but isn't responsive to user needs, and another method which is more responsive to user needs but doesn't scale. Why not join the two together in some way and take the best bits out of each? Which is kind of what Dan's done. It's not really doing him a good service here, but essentially what Dan did was he invented an agile way of modeling, which supports incremental development in a warehouse. And he uses his way of modeling to kind of fit this enterprise warehouse layer in a data vault architecture. Basically brings the data through and borrows on Kimball to look at the presentation layer for consumption purposes. So Dan's thrown a lot of new invention in there, but also based his approach on well-tried and trusted engineering approaches supported by individuals in the marketplace. Okay, so a lot of methods overlap and borrow from each other. Dan's essentially got agile ways of working with borrowing ideas from Kimball and Inmon in terms of how to get the architecture put together. So, moving on, Data Vault. Data Vault's actually been around for about 30 years. It doesn't mean it's old-fashioned. I think it was a bit ahead of its time. And the reason for that is Dan was working for a US government client. Government client needed to build a petabyte scale database, data warehouse, which is huge in the 1990s. And to be able to do that, Dan had to invent an architecture that was very lopsided. It was biased to the delivery of parallel load, minimizing the processing of raw data on load, data integration by topic, and traceability through metadata. So he built an architecture that worked and did deliver for that client at that sort of scale. Now, back in the 1990s, very, very few organizations needed a petabyte scale data warehouse, more at the low terabyte scale, and that kind of scale, a Kimball architecture would be more than sufficient. So most organizations were picking up on Kimball or Inmon approaches for warehousing, and Data Vault was an interesting option, but not necessarily one that answered their particular needs at the time. Okay, so let's wind forward 30 years. We've been through big data, we've been through cloud big data, and now native cloud databases. People are processing larger volumes of data, especially, as you know, with the Gen AI applications that are coming through. The demand for data is growing and growing, and if you've got a large data set that's rich and mirrors your business, then you need what's here: parallel load, minimizing processing of raw data, integration by topic, traceability, and so on. So it's almost by accident in a way, or maybe by design. Dan designed something 30 years ago that was a sort of background interesting method that has been pushed more into the forefront now as organizations need the features that Data Vault offers you. In terms of Data Vault itself, it has Dan is a sort of benevolent dictator in saying what's in the method and not, and he has a test harness he's been developing over the years. I think there's over 30,000 tests in it, and when he recommends a change to the architecture itself, he runs the tests on it to check that the impact is scalable and performant. So it's based on the practical applications. And think about it, in 2015, the book was published, and Data Vault was updated to version 2, and the book effectively public sourced the method. So what was a expensive class to attend, you can now read the book about it and understand what Data Vault's all about. Class is still available and recommended, but you can read about it and understand it. Data Vault itself has undergone continuous improvement. So since the book was published, there's been some developments, and there are continuous developments involved as the marketplace itself learns and works further. So, bringing in things like data contracts, understanding how to feed different types of use case and so on. And there's a very active user community out there working on it. So let's move on here. Here's that book, the reference book, Dan and Michael Onshimka, and it's a good introduction. It's what I would start with as a reference book. It's a bit long, but you can dip in and read parts of it and understand how Data Vault works. There's also a second book out there by Patrick Kuba called The Data Vault Guru, and that's slightly more recent. It's aligned with Dan Linster's view of how Data Vault should work, and it contains a lot of the latest developments in the method. An alternative source for information, I recommend buying the first book first. This book's been basically privately published, so could have done with an editor. Basically, it's a nice book, but could have done with some editing to make the text a bit more clear and understandable. It's a good source for reference as well. Okay, well, that's the first half finished. I need a small break now just to get a glass of water. We're currently at 7 minutes to the hour. If we can come back in 5 minutes, please, at 2 minutes to the hour, we can get started on the next section where we're going more into the technology, how the system works. Okay, thank you very much. Any questions now? Everyone happy with speed and so on? Hopefully it's been interesting for you so far. Technology part is even more interesting, the mechanics of how this works. Okay, we'll see you in 5 minutes. Thank you.
Thank you, Neil.
Thank you. All right, I'm back. Hopefully you're all there. Let's get moving. Let's start looking at the technical parts of Data Vault. So remember, this is what we want to build. So we have two source systems, CRM and order management. We're going to be landing that data using ETL. Over time, we'll add other sources to the mix as we build out the system itself. We're going to have an integrated view of data. That's what Data Vault is. That's where our hubs, links, and satellites sit. And we're going to cut some ETL from there to produce a data product for the marketing team to access. And in the future, we will be adding more data products to the mix for other use cases across the organization. So reusing that data as much as we can to add value for the work we've done bringing the data in. This is an incremental build. We're working in an agile way, so we can work a step at a time and build a very small system to start with, and build that out and incrementally add to it. So first thing we do is just enough upfront design, and by just enough design I mean take a look at the data itself, understand the data that we're going to be working with, and we do that through profiling and data modeling. So what we need to do is to build a Data Vault model for the system that we're going to be building based on the business context of what we're looking at, the sales process in the organization. And what we're going to do is like a bit of top-down, a bit of bottom-up modeling. So the top-down is taking a more theoretical view of what we need to build. That gives us a business view of the data. And then bottom-up is kind of matching what we have into that ideal top-down model and tweaking things to make things realistic based on what we have there. Now there's an anti-pattern, so be aware. If you just do bottom-up modeling only, in other words, if you start from the source systems and model a target architecture from those source systems, then you are going to end up with what's called a source system Data Vault, which is mostly guaranteed to fail in terms of project work. So unfortunately, a lot of the tool vendors out there say, give us a source system and press a button and we can auto-generate you the Data Vault in minutes. And maybe they can, but they will have generated you a source system Data Vault. And you can see a source system Data Vault because you'll have an explosion of tables and difficulty to get data out of the system for reporting. And if you look at some blogs out there, some authors who say they don't like Data Vault, it was problematic for them. They tend to explain this as being the reason they don't like Data Vault, and that means that they've actually not applied the method correctly and ended up with predictable mess in there. So you can't switch your brain off. You have to be thinking while you're doing this work to make sure you're avoiding overly dependent source system modeling there. Right, so we have, here's our source. Yeah, we've got these tables, and they're modeling a sales process. So we have customers are placing orders have order lines are products. So we're going to put our data modeler to work, and we're going to ask them to identify the sort of business concepts that are in this business process. So what things are we acting upon to make this process work? And what I'll probably say to you is that we have three concepts: are customer, orders, and products. And these concepts tend to become the hubs. So hubs are business concepts. So in other words, I can't run a sales process without information about customers, orders, and products. Now, data modeling is a craft, not a science. So we might find that different modelers would come up with a maybe slightly different model. So, for example, someone might not have hub customer, they might put in place their hub organization or hub party. Others might say, oh look, we've got addresses here, we've got postal addresses. I'm going to have a hub postal address in here because that's a concept we need to be aware of for delivery. And we want to know who's sharing the same addresses and so on. So we might create hub postal address as another concept as well. Nothing wrong with those. Each variant is valid until proven otherwise. But as far as we're concerned, we have these three concepts: customers, orders, and products. So next thing is we can add information about the columns or the data that describes these hubs. Attributes describing a customer or an order or a product become satellites. And I'm showing here a satellite as a yellow circle with an S in it. Actually, those are proper tables with lots of columns in them. I'm just showing them as little S's to give me room to draw the picture on the page. But you can still show you some interesting things here. One is that I can have more than one satellite from, subband, yes, postal address can be treated as a business concept, quite right. Yeah, so you've got the option of doing that. In this particular case, it's not important enough for the business to treat it separately, so we're going to add it as an attribute of the customer. But to be honest, if I was modelling this, I probably would have postal address as a separate concept. Yeah, so subband, it's an open debate that you can have, and that's the thing about modelling, is you can have different opinions and disagreements, and those are important to go through to end up with a robust model. Yeah, it just depends on the business case as well, what you want to do. Anyway, so here I have more than one satellite hanging off of hub customer, and what you'll see is that one satellite is linked back to one source table. Yeah, so a source table can feed a satellite. A satellite can only come from the one source table, but a source table could be cut up and fed into more than one satellite. Particularly if a table describes two different concepts, you would move the attributes for one concept in one area and attributes describing another concept to another area. So there we are. We have data mapped into the hubs, descriptive information, and one or more satellites per concept. And finally, we need to add structural information, and that's where links come in. So we have some information about orders being connected to products. So we have order lines. Orders have order lines. The line points to a product. And we have a business event that's happened, that's a customer placing an order, and that draws in the customer and the order concepts in terms of modelling that event. Okay, now the point we're trying to make here is, first thing is, you can see hubs link satellites. There's rules about what they can connect to. So satellites can only connect to hubs and links. Links can only connect to hubs, and hubs can only connect to links. So if you want to connect two hubs together, there must be a link in the middle, a structural event that's causing those to be connected. Okay, so I've got three building blocks here. I've got hubs for concepts. I've got links for relationships between them caused by structure or by a business event that might happen. And then satellites is the payload, the columns that describe those concepts on the hub and link structure. Now, what else can I say in here? No, I'll move on. Now, if you draw a data vault model, we tend to draw hubs in a line across the centre of the diagram, like this, and add the links and satellites to them to get an idea of how there's a crow's foot round a long way there, never mind. So we do this to emphasise the fact that we have concepts that are drawn into processes or structures. So the data vault model tends to be long and thin in nature, and that looks a bit like a spine, back spine. If we just show the hubs and links on the diagram, we call that a Data Vault spine model. And the interesting thing about that is we're only using business terms here. So everything you see here is meaningful in the business context of the process that we're working on. Okay, so there's a limit to how many concepts we can have, a limit to how many relationships we might put in place to describe a particular business process. Now, obviously, I've been through a very simple modelling process here. It's come straight out. You may well sit down with engineers and debate the model and what it should look like. And there's a book written by an Australian who's an agile data architect. He's called it The Elephant in the Fridge, and it's full of nice techniques for building out a data vault and doing this early in modelling and understanding. So he uses ontologies as a way of understanding the data, and shows you how to model and decide on the right terminology and grains for building out this work. So it's worth looking at his book to understand some of the complexity you might come across. Question from Oscar: a hub and a link creates another link? No, links only join hubs. Links cannot connect to other links. If you do connect links to links, you destroy the scalability of the model and you start to introduce dependencies on the load. That means as the system grows, it just slows down and doesn't work anymore. Worth getting a copy. Actually, John's presented at our user group, so we've got a video of his presentation from 2 or 3 years ago. Have a look at that. If you like what he says, you might be interested in getting a copy of the book. Okay, right, so we've built out this model. We should now start building something. Get on with the build. Don't waste much more time designing. So the first thing we do is we need to stage data. We need to bring data in from our source systems. And remember, we've got 2 source systems here. We need to be bringing this raw data in from the source into our data platform. Various ways of doing this. I'm increasingly seeing tools like Fivetran being used for this now, which is excellent. But the basic idea is we're trying to load the CDC information from the source. So I'm trying to get hold of records that have changed since I last loaded data into the system, rather than full table dumps and full views of data coming into stage. We're going to have multiple source systems coming in. We can cope with all kinds of mechanisms, including real-time event pipes. We're not going to cover that off here. I'll talk about the batch process for loading data, but essentially, at the end of the day, the SQL is the same to get the data into the warehouse. Right, so we're staging. Now, in a traditional data vault, this is transient. So the stage is loaded, data loaded into the vault, and then the stage is truncated after that. So the stage only contains the latest view, the latest set of data that we need to be loading, not full history in there. Having staged the data, we now add extra columns. We derive extra columns to this to allow the data to be ready for load into the data vault. We have to add extra metadata columns to it. The way we do this in our data practice is we add views on top of those stage tables, and those views contain derived information in there. And the sort of thing you're going to see in there is, well, let's have a look now. We have source data, remember, coming in from the source. That is staged on a regular basis. Then we put a view on top of those, which adds extra columns. And then we use those views to load into the data vault. Okay, so here's a stage table. We've got the orders table from the CRM system. And we're going to basically add these extra columns in the view. So we would hash the keys. So we have a key for order ID in there, AAA, we'd hash that to get an order hash key. We would add metadata like information about the record source, which would be the CRM orders table, the load date, which would be the date you run the batch, and something called hash diff, which is like a checksum, and we use that to in the satellites to check if records have changed, so to make the load happen. So we're basically going to be creating a view on the stage. Here's some SQL. We're creating the view. We're going to select all the columns from the stage, and then we're going to add, you can see here, an MD5 hash of customer ID to get the hash key out. We're going to add a created date as load date time, so picking a date column as the load time. Put a constant in for the record source, and then we're going to concatenate columns together and hash them to get a hash diff out as a checksum. Okay, so the create view statements are going to be very similar in the patterns that are there, depending on what we need to calculate. Right, so we're now ready to push data into the raw vault. We've got targets, which are hubs, links, and satellites. So think about this. Staging data is tables in the staging layer which mirror the source system tables. And once we push them into the vault, we're effectively going to chop those tables up into smaller bits and attach them to target tables where they make sense. Yeah, so if a table has information about customers and orders, then we're going to cut it up and push the customer information to the customer hub and the orders information to the orders hub. All right, so we're going to integrate by topic by doing this. So hubs we said are entities of significance, so they're business concepts. And you might think about them, they should exist in their own right. And all that's in a hub is just a list of the business keys. It's a very narrow, thin table. So we're going to look out there at the source data. We're going to find appropriate keys we can use to identify each of these concepts. And we're going to end up with information in there. So, for example, okay, so hubs tend to only have 4 columns in there. Let's have a look. So customer, we identified customer ID for the key. Order, we're going to use order ID, and product, we're going to use product ID. And we're going to then create 3 additional columns on that, which is metadata, which is a hash key, which is the hash of the primary key, the business key rather. The load date time, which is the time we load the record into the system, and record source, which is an identifier for where the data came from. So in every hub, there's only 1 column that's come from the source data, and the rest, 3 columns, are derived in the view before loading. So let's have a look. We've got source data from CRM. Here's the data. What we're going to do is we're going to add these additional columns in the view, and then pick the 4 columns we need to feed across to the target hub. Now, as hubs are integrating things, so orders, for example, we may have multiple tables containing order data. So we'll be loading both of those into the same hub. Okay, so if it's a hub product, we'll be loading any product information from anywhere into that hub, and then deduping and mastering the primary keys for that concept in our system. Right, so we're kind of ready to go. We've got the 4 columns lined up. Got our 4 columns in the hub. Hub's empty at the moment. Let's push ahead and load some data. So here we have a source feed. On the 2nd of January 2020, our source A from CRM tells us there's a customer with an ID of 100. Hub was empty, so we haven't seen that customer before. So we load that into the hub record. So we have the hash key, hash of the 100, source A on the 1st of January, with a label, the ID of 100. Day 2, we have 2 records from source A, 100 and 200. They're coming in on the next day, the 2nd of January. Now, In the hub, we've not seen customer 200 before, so we load that into the hub. But we have seen customer 100 before, so we ignore that record. Yeah. So the customer tells us when we first saw that customer, not the second or third or fourth time, the load date remains unchanged for that record. Okay. So you can see there 2 records in the hub, each seen on subsequent days. Right, well, day 3. We're told about customers 200, 300 and 400. So 300 and 400 were new, so we load those in. We've seen 200 before, so we ignore it. But what about 100? It's not in the feed. What does that mean? Well, actually, it could mean that the 100 had no changes to it in this cycle, and therefore it doesn't come through on the CDC feed. It might also mean that record 100 has been deleted from the source. If you notice here, there's no information here about the record being deleted, and there's no information in the hub about the deletion. So we would not update the hub. We would record the deletion usually in a satellite hanging off the hub customer, and there are special types of satellite that we can use to hold status values if we want to. The point is the hub doesn't care. The hub will do nothing because we've not been told about the record 100. Now, this works also with 2 sources. Basically, you get a table lock. So here we have, that should be customer 100 on day 1. That feeds into from source A. We haven't seen that before, so we load the hub. Day 2, we're told about customer 200 from A, so that loads in. But source B is telling us about 100, but we already have seen that record, so we ignore that in the hub. So it's basically the same pattern again. And we can have issues here where we have a 2 arriving at the same time. So day 3, we're told about 300 and 400 from A, 300 and 301 from B. Now, this is the first time either of them have told us about 300. They're both arriving with new information. And it could be that source A gets in first, locks the hub, does its insert, releases the hub, and then source B picks up the hub and inserts its records, finds that system A's got there on 300 before it. So in that case, it would have been loaded already. And that can happen in reverse as well. If here we've got an example where source B gets in first with record 600. So it works with 2, 3, 4, however many sources you have coming in. And if, for example, you're working with Snowflake, I think it will keep the table locked for up to 12 hours, or things queuing for up to 12 hours, if it's waiting for a turn to insert the data. Notice the inserts are quite fast. We're just inserting a narrow row, finding things that are new in here. Now, you may have noticed this, but this is an insert-only architecture, so we only insert rows, we never edit anything once it's in there. Okay, and the other thing you may notice is that we can run the insert in parallel. Okay, so we can run several hubs in parallel, and there's no worry there about overlapping tables. We just say load from these sources, and off it goes, and will sort itself out in terms of how the table works, table loads work. Right, so the SQL to load a hub. Well, every hub's going to have a similar loading pattern, so the SQL's going to look very similar. This is a slightly old-fashioned way of writing it, but essentially we're doing we're inserting into the hub from the staging customer where there are new records in the staging customer. It's a left outer join on the hub. So we find out anything that's new and we push that into the hub. And that means we can template it. So if we have the metadata, like the source table and the target table names and so on, we can just feed them into a generator and the SQL will be generated for you. You don't need to write SQL ever again to do a hub load, and it's all all generated for you without mistakes, high quality code. I've got a question from Stephen. What happens if customer 300 has a different date of birth, say in source A and source B? Well, it doesn't really matter because customer 300, we're only loading into the hubs the primary key, the 300. So different dates of birth are coming in into satellites, and I'll talk about satellites in a moment. Right, so that's hubs basically. Now let's look at links. So links are recording that hubs are related. So either structurally or because some events happened in the business that draws those into each other. And links tend to have 5 columns or 6 or 7, depending on how many hubs are connected to it. So they have a primary key, foreign keys out to each of the hubs that are connected to it, a load date, time, and record source. So let's have a look. The primary key is difficult to explain, but actually very simple to do. We don't want to hash hashes, so we don't want to hash the hash keys. What we're going to do is hash the business keys of the connected hubs in there. And the good news is, if you're creating a link, you'll have access to those business keys as part of the source table anyway. But anyway, the hash key is the hash of the concatenation of the foreign business keys. So customer ID and order ID, for example, would be hashed for that. Foreign keys are pointing out to the linked hubs, and we have load date, time, and record source just the same as the hub. Now, interesting thing to point out here. If you look at those link tables, there's nothing in there that's from the source. That's all metadata, all derived as part of the load pattern. Okay, so a link is mostly metadata in the way it works. So here's our source systems. We found tables where we have information about orders and order lines where both keys are present, so we can use those to help prepare and feed these links. So here's an example. We have our staging table, orders table again from the CRM system. We're going to add extra columns in the view, and be prepared there to feed the target. And just as well, like the hubs, we could have more than one table feeding our link if they have sales data is held in 2 different areas. Okay, so we're kind of ready to go to load that link. So we have day 1, just like before, we have 2 records coming in on source B, which is our website. But people have been placing web orders. The link's empty, so we load them into the link. Day 2, got an order from the CRM and an order from web. Those are non-existing in the link table, so we load those in. Day 3, we start to get some repeat information in there, so we don't load those, we've seen those before. And day 4, got further information coming in here. So it's a little bit like the hub. It's going to insert only architecture, and anything new is added to that link. Anything repeating is not. So that means the SQL for loading the link is fairly consistent. And that means that we can also template that. So as long as we have the metadata, which we get from our tools, we're able to generate the data vault that we need, the link load. Satellites. Now, satellites are a little bit different because satellites hold point-in-time information. What do I mean by that? Well, here we have a customer source data table. We're going to have a hub customer in there, and the satellite's going to describe that customer concept. So there's some payload in the customer record, the first name, surname, phone, and so on. And those go into that satellite. And the satellite's set up to be point in time. So what do I mean by that? And this will answer possibly some of the questions you have. let's say I'm a customer of this organisation, so I started using them a year ago as a customer. So a year ago, my hub record would have been created for me, and satellite would be created at the same time with information about my name and surname and phone and email address and so on. So let's say I've been a customer for this organisation for a little while, and at some point I decided to change my phone number. So that means there's been a change at a particular date, and what happens there is the system detects the change and creates a new satellite row for me in the table. So at that point I'll have two rows, the one with the original information I provided, and then at a later load date, another record with my changed phone details in. Okay, so the idea being that I can go back in time and say which satellite was valid at a particular reference date and work out what we knew then. So I can reconstruct what we knew when across the full history of the records that we have. So the primary key of a satellite is the parent hub's hash key and the load date time. We have a record source like before, and then we have this hash diff, which is a concatenation of the payload columns hashed. So we're going to join together the first name, surname, date, created, phone, email, and so on, hash them, store them in the hash diff. And the hash diff is essentially a change calculated to derive changes in the source. Right, so let's see about loading satellites. We've got data, we're going to be adding these extra columns in the view, and we're going to be pushing that information into a satellite. One table, one satellite, remember, so there's no mixing of these. And basically we're going to insert rows into that satellite based on the loading pattern. So let's see, day one, we're told information about customer 100. As that's new, we would load that information into the satellite. Day two, that customer has asked us to use a different phone number. So you can see there the hash diff, the hash of the payload columns is now different from the day before because the phone number's changed. Okay, and by detecting that change, by comparing the hash diffs, we've decided that we should now load a new row into the record set. And now I've got two records in there for the customer, different dates on them, and the reason there are two rows in there is because there's been a change in that data set. Day three, no change, so the hash diff remains the same, and because there's been no change, we add no row to the satellite. Day four, now I'm told about two customers, so I have no change in customer 100, so no load, but a new customer has arrived, customer 200, so that's loaded into the target satellite. And then day 5, I have two changes. So customer 100 has gone back to the original phone number, which means the hash diff is now back to the original value of AAA. But you compare that to the latest record in there, and there has now been a change. So you've got 3 records in there now for customer 100, and it kind of flip-flops from one record to another and then back again on the different dates. And customer 200 has changed their title to doctor, and therefore there's a change in the hash diff there as well. That's caused a change into the satellite table. Okay, so the satellite's kind of point in time, the history of changes, and the SQL to load that is similar for every satellite. So you basically have to find, here's a CTE at the top where we find the latest satellite records, and then we insert into the satellite if the hash diff is different. And that means we can also template that and generate the satellite load automatically if we've got that metadata. So what's going on? We have all these source tables in green, and the modeling work we did converted them into a data vault model, 3 building blocks, hub, link, satellite. They're the same model, basically. I can reconstruct one from the other. But in the data vault, I've essentially added a time dimension, time capability. That's what these satellites do. So I can actually hold a version of the green model at any point in time by having the load date time value put in place. So whereas the green tables can't track history, the data vault can. Also, what we've done in this process is we've identified a business view of the model, which is the hubs and links. So the concepts and the links connecting them are phrased in business terms, and the satellites hanging off of those are descriptive information from different sources. Okay, so I like to think of it as a bit like a Lego block. You use hubs, links, and satellites as the grammar to describe your business, and you can derive them from the source. So here we go, and now we can generate code for all the load. Okay, so we're now going to look at business rules. So we've loaded the raw data into our hubs, links, and satellites, but we might be needing to add to that data. So we might want to be calculating KPIs or deriving business rules from the data and have that available in the data warehouse for external use. These things are called business rules, and they take that raw data and transform it into something else. Now, what types of business rule could we have? I mean, we might do some cleaning up. So we might rename a column or conform a column to a master. So an example here I always give is one time I was working with a really old computer system, and it didn't have a column for email in there. It did have a column for fax number. So the user said, let's put the email into the fax number column. And when you did a report, cleaning up, we would have to say, actually, the fax number is the email. So we would rename the column to email to make it clear what it was. Okay, and conforming to master, I had one client that operated in 12 countries. Someone made some spelling mistakes in there, and they actually had 15 countries in the list when there should have been 12. And the reason was they misspelled a couple of the countries. So what we did was some cleanup on the way in. The misspellings were corrected to make sure that we had the right names in there, that sort of thing. Other rules, we might have some common KPIs. So we might have things like queue processing information, like time to resolve questions, time to complete a task, average time to close. We might be aggregating things, we might be taking averages, looking for minimum and maximum values in sets, and we could end up with some fairly complicated rules in there as well, but the idea is we're calculating these common KPIs so that the users don't have to, and everyone accesses the same values and doesn't have to rewrite their own calculation of them. We might have a best view. You've seen how we have one satellite, one source. What if I had 20 sources describing customer? I'm going to have 20 satellites on the customer, which is fine. No problem with that. But I might want to have a best view. I might want to know what's the best view of the data that I can have across those 20. So I might have some rules that say, well, take some data from here, take some data from there. If that's a null, then look here. Those sorts of things. And from there we can construct a best view in there, and then we'll be creating a new satellite called a business satellite with that derived information on. And we may even stick some machine learning or Gen AI on the far end as well, and maybe taking some results back from that back into the data vault. So this is kind of how that works. We had our stage data, we extended that with view, we loaded the hubs, links and satellites, we're now going to use the rules utility or write our own rules in SQL and basically generate a new stage table as an output from the rule and load that back into the same vault that we had for building out the data vault itself. Okay, so it's a circular thing here. So if I may have a particular rule that depends on another rule, in which case we go through this cycle a couple of times. But the point is, we're putting the data back into the same vault, the same schema that we had before, and it's a sparse addition to the existing hubs, links, and satellites. Right, now, it's all very well getting data in, but we want to get data out at some point. And it's common to be building dimensions and facts for star schemas, or maybe a big table for output, or some kind of API interface to for external downstream users to access the data that they need. So we need to be working on taking the data that we have out of the door. Now here's a data vault model, and what you tend to find is that your dimensions tend to be named after your concepts. So here we have hub product. We may well have a product dimension, and we have an order dimension and a customer dimension too. Okay, in there. And what we're doing is joining the hub and the satellite together. If you take the latest version of the satellite, you're going to get a type 1 dimension. If you take in the time in there, the creation dates and so on, you will be able to extract a type 2 dimension into there with a history of data in there. And the walk across the top that expresses the business logic of a particular query. So here we've got which customers have placed an order, and of those orders, what products are in there. We are going to construct a fact table from that. So the walk across the business area gives us the link, the fact, and the products and the satellites. Sorry, the hubs and the satellites give us the dimensions. And those can be templated as well. The SQL to extract those columns is fairly repetitive. So we can easily generate dimensions and fact table generation from the data schema that we have. Now, if I'm running a data set load, I'm going to have to do some orchestration in here. And I've mentioned here that I can do parallel load. So the whole thing is designed for as much parallel load as possible. Although there are some dependencies, of course, in there. I have to load the stage before I can load the vault itself. And then I can do the rules after the vault is loaded. And then I can do the data products after the rules have been applied. So there are steps involved here. But essentially, I stage the data. Once the data is staged, I push that data into the raw vault, and then I cycle round, calculating rules. And if they're rules dependent on rules, I repeat the cycle until I've calculated the last rule that's dependent in there. And then I push the data out to the data products. Now, I could be loading hundreds of tables in parallel here. And that's great. It helps to reduce the time taken and speed up the response for loading the warehouse. So the maximum I've ever done here, I did an experimentation here with Snowflake, and we got 20,000 parallel loads running at once into the vault, and working quite nicely with a Snowflake engine. So it's possible to scale this right up. Now, we are going to be agile, aren't we? We want to add value. So really, up to now, all we've been doing is pushing data into a store. And we call that left to right data sourcing, left to right process. But there is a right to left, which is starting with the users and saying, what do you need? What kind of reporting do you need? And are we loading the right data into the warehouse to answer what you need to have answered? Okay, so we need to go out to users and say, what do you need? And can we design our presentation layer here so the data products in the place to meet your user needs for their day-to-day work? Now, getting a definition of the data products is a nice interface between the user needs and the data sourcing side of things. So if we start on the right-hand side, we'll be out asking the users, what are your business questions you need to ask here? And from that, we can work out the business rules that are needed to support those questions and the source data that we need to be in there so we can be sure that we're going out to get it. So our user might say, I need a star schema. Okay, fine. Here's a star schema. We need to have time, geography, product, and sales in there. So the process basically goes like this. We talk to our users about what they need. We design a data product that meets those needs. We then source the data to feed that product. And finally, as the Data Vault architecture does, the whole thing fits together as we assemble it because of the way the database is designed. Right, so we're going to get questions. So the first question we often get is, there's a table explosion, isn't there? Look, we started with 4 tables, we ended up with 11. Lots of tables isn't good on big data. Well, I'd say in here, yeah, maybe, but look, the hubs and the links are the business model. So they contain business terms. If I'm modeling an ordering process, those are probably the minimum I need to have in place to capture that logic. That we have customers that place orders, that orders have lines for products. Satellites, they're pinned on that framework, okay? So there might be a lot of satellites, but they can never really get that complicated because they're attached to that hub link structure. The hub link structure is complex as it needs to be for the problem you're trying to solve. And all the satellites they're just point-in-time collections of a particular source table. So most hubs are going to be very quiet and only have 1 or 2 satellites hanging off of them. And some hubs might be very busy because they're the center of your business and have a lot of things happening around them. That's fine. The point I'm trying to make here is the complexity of the model is driven by the hubs and links, not by the satellites. Second thing is we've got joins, yes, and we should be worried about the join performance. So is joining the data together correct in terms of enhancing performance? Here we're going to have to do a lot of hub link navigation, joining out to satellites and applying window functions, and surely that should be slow running. Well, again, the point we're trying to make out here is that your users do not access the Data Vault directly. They're going to access a data product that you're going to design. First things first. And therefore, you can optimize the data product for your users. Maintaining a normalized form in the center here is good practice because it promotes reuse. So we're not designing the system to solve just one question. We've got a generic statement here that allows us to run lots of inquiries against it for different purposes. Right, so I like Data Vault. How do I implement it in my organization? Well, the thing about it is we have a challenge. And we have today, and we have a legacy architecture, legacy warehouse running. We have to get to the future, which is a Data Vault in place. So how do we do that? You know, it's not going to be an instantaneous process. So that transition is going to take time. It's a period where we're going to have both the old and the new services running together. In fact, that'd probably be a normal state for a long time. If you're going to make that change happen, you've got to change 2 things. You've got to change the skills in your team, and you've got to work on your data platform, the technology part. And in fact, to be honest, the technology change is the easiest bit. It's learning the skills, it's learning the modeling that takes the time. It's a different attitude or a different thought process for what a warehouse is and how to build it out. So part of that mindset change you can address through training. So you can get it is recommended you put someone on a certification training to get certified in Data Vault. And my company offers practitioner training as well if you want to put your developers through a mock project to give them some training on how to build a vault. And there's also the possibility of using some structured coaching with the team to encourage them to use new techniques. I can't stress this importantly enough. If you're going to start moving to Data Vault, you need to show early demonstration of value. Otherwise, your users are going to get fed up and worry why you're spending all this money and not delivering anything. So as Data Vault is agile, you can actually get out a Data Vault solution in a matter of weeks. So my organisation has got this down now to about between 6 and 8 weeks to get your first Data Vault built. And that's typically 3 source systems, 20 source tables, a couple of star schemas thrown in, all done in that time frame. And it's best to pick an unresolved business problem now, something new for the business, so you're showing something that hasn't been done before. And you need to give them something to see so that your management team can understand what it takes to build something and to help your team learn the skills necessary to continue with the delivery. And that's a mindset change needed. There's a lot of new things that need to be adopted by the team. So you've got to learn agile ways of working, understand what iterative development is, understand the automation processes, test-driven development, refactoring, and so on. So quite a bit of change involved in there. You have a challenge if you've got a large team. The transitions are more challenging. Small teams are easier to change. You can get together as a team and agree you're going to do something and just do it. Larger teams tend to have communication issues and worries about what they're doing. So recommended that larger teams are properly coached through the change. So yeah, more people involved, and teams tend to slip backwards if you're not careful. Planning is important. So when are you going to do the training? How are you going to adopt new ways of working? How are you going to coordinate this across the team? And so on, and communicate what's going on. So what are you learning as you're going on this? And then finally, to ensure you get success here, just make sure you plan things and you're engaging your stakeholders and got visibility, you've got training in place, and that you've demonstrated early value to get there. Right, so tooling. Mentioned generation, so there's quite a few tools out there you can pick and choose from. Here's some examples of them. So you've got BimbleFlex, which is an SSIS generator, VaultSpeed, a SaaS version of Data Vault, DataOps, Squarescape, and so on. And of course ourselves, Automate DV on the end, which is a free-to-use tool for generating a Data Vault. All these are out there. All these are potential options for your way forward. Right. So conclusion. We have in features needed in any platform. Proper Data Vault would need to be agile, additive, automation, be in place, scalable, productive, and so on. Data Vault offers all these things, which is why people need a new platform, tend to look at Data Vault as an option. It changes your way of working. If you remember rightly, we're generating ETL, we've got smaller teams, we're working in agile ways, we're refactoring, and so on. The method's evolving all the time. So these are some topics that have been presented at user groups around the world, and plenty more coming up as well. But Data Vault fits well with data mesh. It fits well in a medallion type architecture too. Because it produces semantic data, it can be very useful for data science and Gen AI applications. Remember, we have our user group in place, which we would encourage you to join, please. That has a wealth of presentations from guest speakers, up-to-date copies of the slides used, and a Q&A section So where you, if you have questions about Data Vault, you can post them for the community to answer. And we actually have Patrick Cuba in there regularly answering questions, which is great. So we've got the user group, there's the email for them, sorry, the web address for that. And on our website, we have lots of free material and links out to other people's blogs on What is Data Vault page, which is a very popular one. And finally, we have, oops, don't skip over that. We have, that's the Q&A forum. Finally, we have Automate DV, which is our free-to-use tool. Very well documented on Read the Docs. And we have a Slack channel running, a package on the DBT site or coming from GitHub. And we have very closely in place now a online training module for Data Vault with Automate DV available, so you can learn how to use the package properly. Don't forget our training for developers in place if you're willing to learn more of the same from today, but to get some hands-on experience of building Data Vault for Snowflake. And that's where we are. So mention the conference, that's it. So any questions? Silence. Does that mean you're all happy or you're all asleep? Thank you, Stephen. Hopefully that was helpful. Did I get your question answered? Essentially, you had, say, if they had two birthdays, you'd have two tables coming in that ended up in two satellites. And then you'd have to use a business rule to decide which one was the correct one. But you don't lose data on the way in, you get the audit trail preserved that way.
Yeah, that's great. Thank you. I was just jumping ahead. My mind was racing ahead. But yeah, that was a really good session. Thank you.
Good. Thank you, everyone. I've been doing this for about 3 years, so I've kind of got this down to a reasonably slick presentation. I've just got a new slide set, all nicely done up and artistically decorated, and I've noticed a few typos going through that the artist has introduced. So I've made notes as we've gone through. A few slides need corrections. But apart from that, it looks good. Right, so what we're going to do is we're going to send out a questionnaire at the end of this session. If you fill in the questionnaire, you'll get a copy of the slides. And we may also reach out and be in touch with you independently. In case you've got further questions you need to ask me, you don't feel comfortable asking me in front of a wider audience. So apart from that, enjoy your time with Data Vault. Hopefully see you at the Data Vault user group. So don't forget we have a conference in September in the UK, but we also have a guest speaker coming in online as part of our regular meetup. And that's a speaker from McDonald's in Nordics about how McDonald's have used Data Vault to support their reporting and analytics needs. Quite an interesting presentation there. So please do turn up for that. And I'm certainly planning on learning something that you may find that interesting. Okay, thank you everyone. I'm happy to hang on for a moment if anyone's got any other questions. Otherwise, happy Data Vaulting. Hopefully this has got you interested. Hopefully this has relaxed any concerns you may have had about Data Vault being something very weird. It isn't really, it's just a regularly structured, engineered approach to warehousing. And I particularly like it because of this semantic integration that's so important for today's analytics needs. All right, have a good time and we'll see you soon.
Thank you.
Cheers. Thanks very much.
Very welcome.
Thank you. Thanks.
Thank you.